Experimental study of aerated concrete using fly ash, bottom ash and steel waste. Here we are replacing cement by fly ash, sand by bottom ash and steel waste to add some strength to the aerated concrete. Aerated concrete is relatively homogeneous when compared to normal concrete. The focus of our project is to study the strength and characteristics of aerated concrete using fly ash, bottom ash and steel waste. Steel waste are added to add some tensile strength. Aerated concrete is a cellular material compound of cement and sand matrix containing a large quantity of pores. Aerated concrete is a lightweight concrete which provides insulative, fire and mold resistant. It can be includes block and wall panels, floor, roof panels and lintels. Objective is to find the behavior of aerated concrete, devise methods in such materials and structures to increase the strength and reduce the density. Materials uses OPC of grade 53, sand which passes 2.36 mmc and lime. Specification of lime powder have been shown. Physical properties and chemical properties. Aluminum powder is a main aerating agent which reacts with water and calcium hydroxide to form hydrogen gas which creates pore inside the concrete. Grades of aluminum powder available in the market. Specification of aluminum powder. Fly ash. It is a pozzolanic property and it is collected from electrostatic method. Bottom ash, it is collected from both the bottom of boiler furnace. It doesn't possess pozzolanic property and it has been replaced for sand. Steel waste is collected from the earth waste. Preliminary test. Specific gravity tests have been conducted. This is the formula for specific gravity test. The specific gravity experiment have been conducted. The values have been substituted in the formula. Specific gravity of fine aggregate is 2.67, bottom ash is 1.8 and fly ash is 1.9. C values have been connected to find the particle size distribution of a granular material. Specific gravity of C analysis have been find out. This is the graph shows the particle size distribution for fine aggregate and bottom ash C analysis have been shown. Bulk density test. The bulk density value of bottom ash is 950 kg per meter cube, fly ash is 1260 kg per meter cube and for sand is 1280 kg per meter cube. Fineness of cement is 5% and fineness of fly ash is 7%. Initial setting time of cement is 32 minutes and final setting time is 13 minutes. Design Expert 8 software we have been used for the analysis part and the input values have been given the range. The mix proportion will be output from the Design Expert 8 software. We vary the bottom ash 0 to 20%, fly ash 0 to 20% and steel waste 0 to 10%. If there is no the presence of fly ash bottom ash, it will be as shown as 0 or dash. Mix ratio is 1:3. Mix proportion is 1:3:0.3. Lime is kept constant as 0.3. This is how we calculated the volume of cube. The cube we use is 0.15 into 0.15 into 0.15 meter cube. So the volume have been shown in the table. This is a mixture of concrete for cubes. The total mixture we have used for each proportions. For beam, 0.1 into 0.1 into 0.5 meter cube volume of beams. So this is the mixture of concrete for beams. Density have been found out. This is the weight by volume for each concrete cube. We have found out the density value. This is the actual weight is 6.75 kg. It ranges from 4 to 5 kg and the actual density is 2000 kg per meter cube. It ranges from 1200 to 1500 kg. The aerated concrete. Bottom ash gets increased, density gets reduced. When the aluminum powder gets increased, the density gets reduced. Because when the aluminum powder gets increased, the aeration process is also gets increased and density gets reduced. This graph shows that bottom ash gets increased, the density gets reduced. This is the compressive strength. It is a physical property of a concrete. It generally forms and one of the most used in design. And the concrete cube is tested in the UTM machine. Steel waste is increased, compressive strength gets increased, and the water cement ratio gets increased. The compressive strength also gets increased. See, aluminum powder gets increased, compressive strength doesn't change much. It is constant. It doesn't react any change in the compressive strength. Flexural strength is also known as rupture strength, bending strength, or flexural strength. It is also tested in the UTM machine. So steel wedge gets increased, compressive strength will also gets increased. When aluminum powder gets increased, it doesn't change the flexural strength, so it's constant. When steel wedge is increased, see the flexural strength also gets increased. Next is softivity testing. This is the table shows the load, compressive strength and flexural strength. Softivity testing, this is absorption testing. Cube is painted all over the surface except the top and bottom, and then it is kept in the sand bed, and first the dead load is measured, that is the initial weight, and the weight is measured for first 30 minutes for every half an hour, next 30 minutes for every 10 minutes, next 30 minutes for every 15 minutes, and goes on. The change of weight is measured by I is calculated by del W by rho into A. Rho is density, A is cross section of the cube. Softivity values for run 2. This is we have to find out for all the 26 runs. The only 2 examples have been shown. Softivity value is I by T half. T half is root of time. This graph shows how the change in weight of the specimen gets increased for every root of time. This is for run 20. See this graph first gradually increases to a certain level and it's constant after some time. When water cement ratio gets increased, softivity gets increased. When aluminum powder gets increased, softivity gets increased. Water cement ratio gets increased, softivity gets increased. This is the input values given for the class except the carbonation testing. So it will give us the analysis and give us the output graph. So carbonation testing is to find the corrosive resistance. So phenolphthalein is sprayed over the surface of the concrete, and after a few days the color of the phenolphthalein gets changed to normal color. The density ranges from 1200 to 1500 kg per meter cube, lesser than brick. The density plays a major role in this. The composition gets ranges from 1 to 3, and flexure is also 1 to 4. Softivity ranges from 0.1 to 0.4. The permeability of the concrete is below the level. This is the reference we have used. Only few references have been added. Thank you.